Hey, it's Mr. Allred, and we're going to solve some quadratic equations. I know we've been doing that a lot lately, but we're going to solve some using the square root principle. And if you recall up top here, the square root principle says if x squared equals a number, then we can basically say that x is the positive and negative square root of that number. And we'll see a little fun example as well as we go through this. But A here, 9x squared minus 16 equals 0. So the main thing we got to do here is focus on getting that square part by itself to begin with. So we can move the 16 over. So we'll have 9x squared equals 16, and then we can divide by the 9, and we'll have x squared equals 16 over 9. So when we apply the square root principle now, the d is the 16/9, so it'll be plus or minus the square root of 16/9, which gives us the answers plus and minus 4/3. Everything may not have a nice square root. You could still get to it using the square root principle in some cases though. B, 3x squared equals negative 18. So here, there's the x squared. We need to get rid of the 3, so we'll divide it out, and that'll give us x squared equals negative 16. We'll apply the principle, because now d is the negative 16, so we get x equals positive and negative square root of negative 16. You might be able to do this in one step, but we need to get that negative out from under the root, so plus or minus the square root of 16i. And then square root of 16 is 4, so we'll have positive and negative 4i is our solution. Okay, and we could write those separately if we want. The last example here is the quantity of 2x plus 3, and that's all squared, equals 144. So while it's a little bit different than the others, the left-hand side we have something squared. So the x up top is more or less a placeholder in the principal formula. So we have something squared. So we can apply the square root principle. And that would mean on the left we'd have 2x plus 3, and on the right we'd have plus or minus the square root of 144. Now keeping that going, that'd be 2x plus 3 equals plus or minus 12. Now, since that's an actual number there on the right-hand side, we need to make two different equations here. So let's say we set up one equation, 2x plus 3 equals 12, and then a second one that is 2x plus 3 equals negative 12. So this one's going in a little bit different direction, but we're still using the principle. The other option would have been in the beginning to square that thing out and pull everything to one side and either try and factor or use the quadratic formula. But you may feel this is better or worse. It's really your choice. But 2x plus 3 equals 12. Getting the x by itself, we get down to x equals 9/2, which we should be able to go back to the original and verify. The other one, 2x plus 3 equals negative 12. We'll solve that. And it looks like we'll get x equals negative 15/2. Once again, we should be able to take that back to the top and verify it if we wanted to. Okay? But we solved all of these using the square root principle, which means we didn't use the quadratic formula. We didn't factor them. But we did have some very special situations here where we had an x squared and a number, or something squared and a number, and then we could get it by itself. All right.